What's up guys, my name is Yabi Silvers and today we're going to be talking about the physics of soccer.
Virgin Brian Beats.
C'est passé dans le centre, Lucas.
Allez.
Second poteau, Pavard.
Before jumping into the physics of soccer, first we need to ask the most basic and fundamental questions, such as, what is soccer? Well, soccer is a sport that has been played for many, many centuries, and it is the most popular sport in the world. In fact, tournaments such as FIFA World Cup and Champions League attract millions, if not billions, of views across the world. With this in mind, we can ask more complicated questions such as, what enables a soccer ball to move? Does air drag affect the way the ball moves? If yes, how? What happens if we kick a soccer ball in space? What is the Magnus effect? And many more. Question 1. What enables a soccer ball to move from one foot to another? There are many forces that contribute to the movement of a ball, but before listing these forces, it is important to understand that without a force acting on the ball cannot move. Understanding this, the ball first must experience an impact that has the ability to move it, which is a force of F kick. However, this depends on how the ball is kicked. If, for example, the ball is kicked up in the air, gravity and air drag will play a huge role in determining its speed, acceleration, and velocity. But if it's kicked on the ground, the force of friction will slow the ball down. This is the embodiment of Newton's first law of motion because the ball cannot move without a force acting on it, and the ball stops moving because forces like friction and air drag will stop it from moving. Another frequently asked question is, can air drag affect the way the ball moves? Well, the answer is yes. As I've mentioned before, air drag is known as the force that opposes motion, so it very much will affect how the ball moves. As the ball slices through the air will resist it, and the gravity of its resistance will depend on the magnitude of the drag force, the shape, the size, and the conditions of the weather. If, for example, a game is being played in a place where there is a lot of wind, the pass will be less accurate. Speaking of places, let's talk about the stadiums. Does playing in a closed stadium versus an open one affect how an athlete plays? First of all, the purpose of a closed stadium is to offer favorable conditions to players in places where there is inclement weather. This offers the opportunity to play indoors, where extreme weather conditions like wind and rain won't affect the way the game is played. Also, the cost of retractable roofed stadiums are substantially higher than those that are open air. Besides the weather difference, the crowd noise is actually amplified. This is because there are walls inside these stadiums that provide no room for the noise to escape, so the walls echo back the noise, constantly changing the destructive zones. In order to show you how this all works, first I'm going to run a simulation of a sound wave coming from a single source. Then I'll create obstacles, 4 different obstacles, to recreate the atmosphere of a stadium. Okay, I just finished creating the box and I will be running the simulation, and the wave is going to be coming from a single source. And as you can see, when the wave is moving, it's moving in a circular pattern, and when it touches the walls, it bounces back off, acting like an echo. And when it bounces back off, it interrupts the other waves that are incoming and creates constantly changing the destructive zones. And this also amplifies the noise because there is a huge increase in the amplitude. Despite this amplification and loudness of the volume, the noise is actually not clear, and that is why in stadiums people hear
Past Vieira, past Dixon. Comes back at him. It's a wonderful run from King.
crazy, right? However, if a team has home court advantage, the noise level will act as a physical motivator, increasing the performance of each athlete. So at the end, closed stadiums do affect how athletes perform. Since stadiums are so important to soccer games and sports in general, I researched a specific soccer stadium called Old Trafford and built a Lego version of the soccer stadium that belongs to the mighty Red Devils Manchester United, which also happens to be my favorite soccer team. Since acceleration due to gravity differs in places, how does this affect soccer games being played in two different places? First, acceleration due to gravity differs in places because the Earth is not a perfect sphere, and the points near the equator are farther from the center of mass. This gravity map is the most accurate model of gravity around the world, recorded by European Space Agency GOCE satellite. Since the distance between the center of mass of two objects affect the gravitational force between them, the force of gravity on an object is smaller at the equator compared to the poles. This causes the gravitational acceleration to be less at the equator than at the poles. For example, a soccer game is being played in Colombia, which is on the equator, and the other in Argentina, one of the closest countries to Antarctica. The acceleration due to gravity is different in these two countries. To demonstrate this, I chose the southernmost city in the world, Ushuaia, Argentina, or better known as the end of the world, and Bogota, Colombia, the most populous city on the equator. First, I looked for the elevation or height above sea level for both cities. Ushuaia was 15.5 meters at bay, and Bogota was 2,556 meters. And once I did, I added them to the radius of the Earth because none of them were below sea level. But if it was below sea level, I would have subtracted. Afterwards, I used the equation g equals gm divided by r squared for both to find gravity. And in Ushuaia, it was 9.83 meters per second squared. And in Bogota, it was 9.82 meters per second squared. I mean, there isn't that big of a change in acceleration due to gravity because Ushuaia is close to Antarctica, but not actually on the poles. So it makes sense that gravity is not that different there. And also, given that Terra del Fuego is very mountainous, there's a difference between G at bay versus G at the top of the mountain range because the elevation will be higher. Therefore, this will change gravity, and the players would actually need oxygen tanks because they cannot breathe at such a high elevation. Also, I tried to see if it really affects how long and fast it would take a ball to fall, and as you can see, it does a little bit, but it does not. It's not perceivable to the human eye. Okay, let's take this a step further. What happens when you kick a soccer ball in space? Well, all Newton's laws of motion take place in this action. First, the ball will keep moving until a force acts on it. Second, the force applied to an object changes the object's acceleration. Third, every action has an equal and opposite reaction. So if one is able to kick a soccer ball in space, the ball will continue to move in the direction that it is kicked, with a constant speed and velocity, until another force acts on it. Keep in mind there is no friction or air drag, which are both forces that oppose motion, so the ball has the ability to travel farther and faster than it can on Earth. Also, the person who kicks the ball will be going in the opposite direction. Another frequently asked question is, can the weight of the ball affect the way the ball moves? The weight of a ball can affect the way the ball moves because weight is a force that is always directed towards the center of the Earth. It is a force that is caused by gravitational attraction of the Earth. Also, weight comes on a spectrum. Something can be as light as a feather or heavy as a planet, which determines how fast something falls because gravity is acting on it, and this concept applies to soccer. As for FIFA and World Cup guidelines, a soccer ball should be 1 pound, or 453.6 grams. Since a soccer ball is inflated with air, the weight is distributed around the outside of the ball. For example, a soccer ball that is 3 pounds will fall much faster, will require more force to hit, and will hurt more to kick than a soccer ball that weighs 1 pound. Not only will this ball require more force to kick, but also friction will play a role that adds to the force that is initially required. If a ball needs to move at 11 meters per second, how much force will it require to move at that speed? First, I converted 3 pounds to kilograms, which equals 1.36 kilograms, and 1 pound equals 0.454 kilograms. Then I created a free body diagram, and since the coefficient of static friction is 0.35, I plugged this into A equals F kick minus FF, which is force of friction, divided by M, which is mass. As you can see, the ball that weighs 3 pounds requires significantly more force to move than the one that weighs 1 pound. Soccer balls are kicked in many different ways, so can the axis of rotation vary depending on how the ball is kicked? The answer is yes. This is because the direction of the force is perpendicular to the axis of rotation, a rotation around a fixed axis. So the axis of rotation can vary depending on how the ball is kicked. For example, the axis is vertical, the lift force will be horizontal, and the ball can be made to curve to one side. If the axis is horizontal, the lift force will be vertical, and the ball can be made to dive or loft depending on the direction of rotation. Also, the strength of rotation is directly related to the rotational speed, which determines how long, wide the ball curves. Since the axis of rotation can vary depending on how a ball is kicked, can soccer cleats affect the movement of a soccer ball? The role of cleats is to reduce players' friction with the ground, helping an athlete run faster. Now, cleats have become so advanced, providing unimaginable comfort, high traction, stability, and cool design patterns. Also, a shoe design can have substantial influence on sprinting performance, improving kick accuracy, and influences maximum kicking velocity. These perks can give a player an advantage over other players because shoe construction has an influence on maximum kicking speed during kicks, even if the ball velocity is dependent on impulse transfer from the leg to the ball. Some cleat designs have friction bumps because more friction between the shoe and the ball will prevent slipping during contact and thus cause better precision. However, the ball will not move fast because friction is acting on it. Overall, soccer cleats do very much affect the way the ball moves. Finally, the most anticipated question. How do you curve a ball? What is the Magnus effect? Named after Gustav Magnus, a German physicist, it is a phenomenon of generating a sideways force on a spinning spherical solid in a fluid. In soccer, it occurs when a player kicks a ball off-center, causing the ball to spin and curve during flight. A perfect example of this is Roberto Carlos' 1997 free kick. As you can see, the ball spins. Friction between the ball and air causes the air to react to the direction of the spin of the ball. As the ball undergoes top spin, the spin around an axis perpendicular to the direction of travel causes the velocity of air around the top half of the ball to become less than the air velocity around the bottom half of the ball. Top spin produces a downward swerve of a moving ball, greater than the one that would produce by gravity. And backspin has the opposite effect. As the ball picks up speed, air on the front side of the ball is going in the same direction as it spins, and therefore it gets dragged along with the ball and deflected back. Air on the other side is moving the opposite to the ball's spin, so the flow separates from the ball instead of getting deflected, which means the ball pushes air one way, so the air applies an equal force on the ball the other way, which is the third law of motion.